Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it. Okay, hello. In this video, I am going to be giving you a very brief overview and introduction of organic chemistry. And in the videos that follow this video, I will be focusing on naming. So most of the videos that I'm going to be preparing for organic chemistry are going to be for naming of the organic compounds. Okay, but in this video, I'm just going to give, it's an introductory video. I'm giving a brief overview of organic chemistry, some important properties that I would like you to remember and take note of, and some important characteristics of organic compounds. Okay, it's not going to be a very detailed introduction. It's just going to be very brief, and it might be a short video. Okay, so let's get right into it. So firstly, what is organic chemistry? What is organic chemistry? Okay, well, in simple terms, organic chemistry is essentially the chemistry of carbon. Okay, so it's the chemistry of carbon. It's basically the study of how carbon behaves in chemical reactions. Okay, so it is basically the study of carbon. Organic chemistry is the study of the element carbon. Okay, and the compounds that are involved in organic chemistry are generally all carbon-based compounds, except your monoxides, your oxides, basically your oxides and your carbonates. So what are your oxides? Your oxides are carbon monoxide, which is given by that formula, a carbon dioxide, which is given by that formula, and your carbonates as well. Okay, so your carbonates are also generally not considered organic. Okay, so basically almost all, if not all, your compounds in organic chemistry, compounds that have carbon in them are organic compounds, except these elements, your oxides and your carbonates. Okay, so that's basically what organic chemistry is. Now, what are hydrocarbons? Well, hydrocarbons are compounds in organic chemistry that are made up of just hydrogen. That's why you have hydro in there, and carbons. Okay, so they are compounds that are made up of hydrogen and carbon atoms. Okay, so those are what your hydrocarbons are. So for instance, you can have CH4, which is a hydrocarbon. Okay, so it is made up of carbon and hydrogen atoms only. That is what hydrocarbons are. Okay, so basically that's what organic chemistry is. It's the chemistry of carbon, and hydrocarbons are compounds in organic chemistry. They are organic compounds that are made up of just carbon and hydrogen atoms only. Okay, so now, since organic chemistry is the chemistry of carbon, there's some important properties about carbon that we need to understand, because we're studying organic chemistry and chemistry is the chemistry of carbon. We need to understand some characteristics of the atom carbon, okay, or the element carbon. Okay, so let's have a look at carbon for a bit. Okay, let's have a look at some important characteristics of carbon. The first, and I think most important characteristic of carbon that I would like you to remember, is that carbon has 4 electrons that it is willing to share with other atoms. Okay, so it has 4 free electrons. We call this property, or this tendency of carbon to share 4 electrons with another element or with another atom, valency. Okay, so we say that carbon has a valency of 4, meaning that it has 4 electrons that it is willing to share with other elements in order to form compounds. Okay, the rest of its electrons it doesn't want to share. It only wants to share 4 electrons, and carbon always forms, okay, as far as we're concerned in this section, carbon always forms bonds with all of its electrons, all of its available electrons. Okay, it uses all of its available electrons to form bonds. Okay, and the types of bonds, right, the types of bonds that this carbon atom forms with other elements is called covalent valent bonds or covalent bonds. Okay, doesn't really matter how you say it as long as you spell it right? So it's covalent bonds or covalent bonds. What does this mean? This means that this carbon has a tendency to share its electrons equally with the elements that it's sharing its electrons with, right? Hence the co. So co means we are sharing, right? A carbon doesn't want to attract an electron from another element more than it's willing to give its own electron to that other element. So if there are two electrons to share between carbon and another element, those electrons will tend to be shared equally so that there is no net charge on the compound that you're looking at, right? If carbon attracts an electron more than another element, then the compound that is formed will be more negative towards the carbon side, right? It'll be ionic, so it'll be more negative, right? But you don't get ionic compounds in organic chemistry. You get basically compounds that are pretty much neutral, right? They don't have a charge. Okay, so that is very important to understand about carbon. It forms covalent bonds with other elements. Not only does it form covalent bonds, it wants to share all of its electrons with other elements, right? It wants to share all of its electrons, but it only has 4 electrons to share. Okay, and the chain formed by your carbon. So if you have a carbon chain, right? If you have carbons, and then you have a hydrocarbon here, right? Remember, we're dealing with hydrocarbons, so it's only compounds that are made up of hydrogen and carbon. If you've got a chain like that, for instance, a chain that looks like that, these chains tend to be very strong, and they tend to get stronger the longer they get. Okay, they tend to get stronger the longer they get. Why? Because these bonds are quite strong. The covalent bonds are quite strong because the electrons are shared equally. So when these compounds are dissolved in, say, water, for instance, something ionic, we have less effective collisions. Okay, you have less effective collisions because by effective collisions we mean collisions where reactions can take place, right? You have less effective, they are less effective, so collisions don't result in effective reactions, or they don't result in reactions taking place because the bonds are so strong because of that tendency of your carbon to want to share the electrons equally. Okay, so the longer the chains become, the stronger your compound is, okay, and the less reactant it becomes. Okay, so so that's basically the property. Those are the properties of your carbon. And look at this compound that I've drawn out here. Remember what I said about your carbon having 4 electrons that it wants to share. It has 4 electrons that it wants to share, and each pair of electrons is represented by a line, right? It's represented by a line. So one line represents 2 pairs of electrons. One pair coming from the other compound, one pair coming from your carbon. So let me demonstrate this quickly. If you've got your carbon there, remember your carbon has 4 electrons that it's willing to share with other elements. Well, other elements will come and share their electrons with carbon, right? And then they will form covalent bonds. In this case, we're dealing with hydrogen. So because we're dealing with hydrocarbons, the hydrogen will come and share one of its electrons. Since hydrogen has only 1 electron to share, right? Hydrogen, unlike carbon wants to share 4 electrons. Hydrogen wants to share 1 electron all the time, right? All the time. Okay, so these electrons are shared between your carbon and your hydrogen, and you can represent these bonds here using just lines. Okay, you will have seen that I was drawing lines earlier on. So instead of showing the actual electrons, know that each line represents 2 electrons that are being shared between the atoms or between the elements. Okay, so that is a very important property. Carbon always wants to share all of its electrons with another compound, and you will notice in this compound that I drew here that all my carbon atoms has 4 bonds around it. All of them have 4 bonds around it, right? If you look at this carbon atom, it has 1, 2, 3, 4 bonds. Okay, if you look at this one in the middle, it has 1, 2, 3, 4 bonds. Okay, and if you look at this one, the third one, it has 1, 2, 3, 4 bonds. Okay, so that's a very important property to remember, and you should remember it for the rest of the section. Okay, so those are your properties of your carbon. Now, the types of hydrocarbons that we will be looking at are called aliphatic, right? Aliphatic compounds. So in organic chemistry, we have two kinds of compounds. We have compounds that are aliphatic, and we have compounds that are aromatic. Okay, so we will be initially looking at just aliphatic compounds, which are basically compounds that form open chains with a few exceptions. They form open chains. By open chains, this is what I mean. I mean, you've got an open, you don't have a closed chain. You've got an open chain of compounds. There's, you say, you've got bonds here all around, and this is a chain. You can see that it's a chain and it's open. It's not closed. It's open. But you have a few exceptions where you can get a closed aliphatic compound, but they're generally open chained, and these ones are closed. Okay, aromatic compounds are closed chains. Okay, but you can get an aliphatic compound that is closed, but I'm not gonna go into that into this video. I'm just giving a quick brief overview of organic chemistry. Okay, so we're gonna be looking at our initially we're gonna be looking at aliphatic compounds. Now, what are our aliphatic compounds? These are the compounds that I will be focusing on in the next video. So our aliphatic compounds, right? Our aliphatic compounds are three. We've got three aliphatic compounds. We've got alkanes, okay? We've got alkanes, we've got alkenes, and we've got alkynes. Okay, we've got alkanes, alkenes, and alkynes. Now, the difference between these three groups of compounds are the number of bonds, of carbon to carbon bonds that they can accommodate. Okay, the number of carbon to carbon bonds that they can accommodate. So alkanes have single bonds between all their carbons. Remember, carbon always wants to have 4 bonds around it. But in this case, let's say you've got a compound that looks like that. You'll always have single bonds, right? Single bonds around your carbon. This is what makes a hydrocarbon an alkane. If all the carbons that you see in the compound are alkanes. Okay, another example would be one that looks like that. Okay, I'm not going to give out the names just yet. That'll be the topic of the next video, like that. Okay. And then you can get alkenes. You can get these are alkanes. All the carbons have single bonds, right? Then you have what we call the next group of aliphatic compounds. We call them alkenes, right? And our alkenes are distinguished by double bonds, okay? So even if it's one double bond, so if you have a carbon like this, you've got a double bond like that. This is 2 bonds already. Remember, how many bonds does carbon want to have? 4. It always wants to have 4, so you will have a compound that looks like that, and then you'll have another carbon there, and then 1, 2, 3, 4, you've got that, you've got that. So if you look at these carbons here, both of them have 4 bonds around them. If you look at this one, it has 1, 2, 3, 4 bonds, so you can't add anymore. Okay, and this is a double bond, so this is an alkene, right? If you look at this carbon here, it has 1, 2, 3, 4. Right, so it is an alkene. It is not an alkane like we started off with. And you will agree with me that since this can only accommodate 2 bonds, right, the simplest alkene is the one that I've drawn up about. I can't draw one like that, right? I can't have something like that because you can't have a hydrogen there, because the hydrogen wants to give away 1 electron, and I've got what there? I've got 4. Remember, one line represents a pair, and I've got 4 here. I can't have 4. You know, so you can't have an alkene with 1 carbon atom. Okay, right. And the next, okay, so these are what alkenes. Alkenes are represented by a double bond. Even if you have a longer chain, as long as you see 1 double bond, as soon as you see 1, let's say you've got that, then you've got that, right? Remember, carbon always wants to have 4 bonds around it, always 4, right? This is the hydrocarbon. Carbon always has 4 bonds around it. So here you need 1, here you need 2 more, right? This one has 4 lines around it. 4 lines. This one has 1, 2, 3, 4 lines. And this one has 1, 2, 3, 4 lines. Okay, so this is indeed an alkene. Okay, and then another type that you have are alkynes. Okay, are alkynes. Alkynes, right? So alkynes have triple bonds. Okay, so alkynes have triple bonds, right? They have at least one triple bond, at least one triple bond. So if you have a compound that looks like that, and then you've got 1, 2, 3, and then you've got another carbon there, right? Triple bond between carbon to carbon atoms. So now each of these 2 carbon atoms, right? Each of these 2 carbon atoms have 3 bonds already. They have 1, 2, 3 bonds. 1, 2, 3 bonds already. So each one of them needs one more. So that's why I added just one here and just one there. And then you've got hydrogen and hydrogen. Okay, and that's it. So that's what makes an alkyne. An alkyne is you get an alkyne when you get a triple bond between carbon and carbon. Okay, so just to go back quickly before I move on, alkanes are distinguished by a single bond throughout, all the time. Throughout, it's a hydrocarbon. So in other words, it's a compound that's made up of hydrogen and carbon atoms, and it has a single bond throughout. Okay, a single bond throughout, right? Single bond between atoms throughout. An alkene has at least one double bond between carbon pairings, okay, or between carbon to carbon bonds. It has at least one. It could be more than one, and the chain could be longer, as I've shown here. Chain could be longer. Load shedding. Load shedding. Anyways, let's learn in the dark. Alkenes have at least one double bond, right? At least one double bond, and alkynes have at least one triple bond. And what you should please remember, it's one of the most important characteristics when I started this video that I said you should not forget, is that carbon always around it, always has 4 bonds around it, because it's only willing to share 4 electrons. It always has 4 bonds, okay? Each and every single carbon atom, if you look at this carbon atom, it has 1, 2, 3, 4. If you look at this carbon atom, it has 1, 2, 3, and 4, right? 4 bonds, okay? And if you go down here, this carbon atom has 1, 2, okay? This is a double bond, so it's 1, 2, this one. Okay, sorry, this one. This one has 1, 2, and 3, and 4, right? And if you look at this one, it has 1, 2, because it's 2 lines, and 3 and 4. This is very important for you to understand and to remember about carbon, right? 4 is the magic number. Okay, every time, all the time. Even here, look at, you've got 1, 2, 3, and then you've got the 4th one around this carbon. If you look at this carbon, you've got 1, 2, 3, you've got the 4th one around that. Okay, so that is a very important property that you need to remember about carbon. Okay, I'm a bit sick. Okay, so cool. That's what. Remember, these are your aliphatic compounds, and your aliphatic compounds are your alkynes, your alkenes, and your alkanes, right? Okay, now the next important thing to know about your aliphatic compounds are the general formulae. Okay, the general formulae of your aliphatic compounds, and I'm just gonna, you don't actually have to memorize this. You can actually derive the formula. You don't have to memorize. I'm not a fan of memorization. I'm a fan of understanding. If you understand something, then you can work it out. You can work out what it's supposed to be, right? So you've got general formulae. You've got general formulae for these aliphatic compounds, okay? For aliphatic compounds. Aliphatic compounds. I'll show you how to work out the general formula. Aliphatic compounds. Okay, so the general formula, or the general formulae for aliphatic compounds are as follows. Okay, so let's say you've got, let's start with alkane, right? Let's draw the structure of the simplest alkane. The simplest alkane is this alkane here. Okay, this happens to be methane, but never mind the name for now. We will focus on that in the next video. This is alkane, right? How do we know that this is an alkane? Firstly, it's made up of only carbons and hydrogens, right? Does the structure make sense? Well, let's see if our carbon has 4 bonds around it. We've got 1, 2, 3, 4. Okay, cool. So far, so good. We know that this is a sensible alkane to have. It exists. It's true. Okay, so now, what is the formula? What is the general formula of an alkane? Well, let's draw another alkane and compare the two, see if we get something similar. Let's draw the second alkane. Say we draw, remember, an alkane is a hydrocarbon with single bonds all around. That's all it is, okay? It's a hydrocarbon, meaning a compound made up of carbon and hydrogen, and it has single bonds all around. Okay, so all around it, it has single bonds. Okay, so this is what this is my second simplest alkane, right? So now let's look at the first one. The first one has 1 carbon and 1, 2, 3, 4 hydrocarbons. Okay, so let's see. Let's try to write that down as a general formula. Say it has 1 carbon, right? So you've got 1 carbon and you've got how many hydrogens? You've got 4 hydrogens. Okay, so let's write down the second one. Let's write down the formula for the second one and see what we get here. Okay, so this is C, this is C, this is 2 C's, right? So I'm going to write down C2, and how many hydrogens do I have? Well, this is 1, 2, 3, 4, 5, 6. I've got 6 hydrogens. Okay, interesting. Let me write down a third final one. Okay, let me go down here and write it down here. No, I'm messing up the order now. So you've got, let's say I've got, remember, all you have to do is have carbon and make sure that carbon has 4 bonds all around it, and make sure that all those bonds are single bonds or single lines in order to have an alkane, right? And make sure that all the bonds are with hydrogen. That's easy. It's easy to come up with an alkane. Okay, so here's another alkane here. It has a name. I'm not gonna go into names right now. So what happens here is that, okay, I have how many C's? I've got 1, 2, 3 C's, right? So this is C3, and I've got H. Now, how many H's do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 here. Okay, now what's common between these three? All of these are alkanes, so all of these have single bonds all around them, and all of them are bonded with hydrogens. Let's see if we can establish something similar about all of these three. Right, so for the first one, we've got 1 carbon and we've got 4 hydrogens. For the second one, we've got 2 carbons and we've got 6 hydrogens. For the third one, we've got 3 carbons and we've got 8 hydrogens. Okay, so let's see if we can come up with a formula here. Let's say whatever number of carbons we have, we're going to call N, right? Whatever number of carbons we have, we are going to call N, right? So this and that and that, we're going to call N, N, and N. Okay, so how do we use this N that we have already to come up with this number? How do we use this N to come up with that number? And how do we use this N to come up with that number? Let's start with the first one, C1H4. 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 How do we use this N? Remember, our N in this case is 1. How do we use it to come up with the number 4? Let's see. Okay, so if N is 1, then in order for me to get to 4 using N, then I must say, I need how many of these N's do I need to get 4? Well, I could do it in different ways, right? I could say I need 4 of these N's, right? I need 4 of these N's. Or I could say I could say there are so many ways of doing this thing, so I'm just going to try out a different few ways first. I could say I'm going to need 3 of these N's, right? Because N is 1, then I'm going to need plus 1, okay? Or I could say I need 2 of these N's. In this case, N is 1, so 2N plus 2, because 2 times 1 is 2 plus 2 is 4, right? So I could go from 4, I could go from 3, and I could go from 2, okay? But what I want you to do is I want you to use the 2. Okay, so this is something that you're just going to have to remember. I want you to use the 2, the one with the 2. So the N, I want to pair my N with the 2 and add on whichever number that I need. Okay, so you don't use this and you don't use that. This one just happens to be the one that will work. So the N, I'm going to use with 2's. Okay, so this N I'm going to use with 2's. I'm going to multiply this N by 2 so that I have 2N, and whichever amount that I need to get to my hydrogens, I will use that amount. Okay, so let me just explain that a bit better so that it's clearer. If I have C1H4, right, and I say this is N, right, that is N, and I want a formula for this compound here, then what I'll do is, in order for me to get my number of hydrogens, for me to get my number of hydrogens, I want to take this N, right, multiply it by 2 and add whatever is remaining in order to get that number there. Okay, so let's do it for the other compounds. Remember what our compounds were? I had C1H4, I had C2H6, and I have C3H8. Let me do it for C2H6, right, C2H6. Okay, so for C2H6, I've got C2H6. This is N, right? I call that N. So since my N is 2, in order for me to get the number of my hydrogens, which is 6 there, I will say 2 times N, right? That's 2 times N. Now, how many more hydrogens do I need in order for me to get to 6? So how many hydrogens do I have already? I have 2 times N, right? I have 2 times N. What is my N? My N is 2. So I've got 2 times 2 already. How many more do I need? 2 times 2 is 4, right? 2 times 2 is 4. So I need 2 more in order to get to 6, right? So then this is going to be plus 2. So then what I'm getting is 2N plus 2. Easy peasy, right? Let's do it for the third one. The third compound is C3H8, right? C3H8. Remember, I'm still looking at alkanes, right? So my N in this instance is 3, right? Okay, my N is 3. Remember, I want to multiply, in order to get my H, I want to multiply my N by 2, right? Plus, how much do I need in order for me to get to 8? Well, if I've got N is equal to 3, right, and I'm multiplying that N by 2, what I'm getting here is 6. How much do I need to add to 6 in order to get to 8? I need to add 2, so I can just add 2 here. So we realize that for all of my alkanes, I've got 2N plus 2 here. I've got 2N plus 2 up there for my second compound. For my second compound, which was C3H8, and I've got 2N plus 2 for my first compound. So all of my compounds end up with 2N plus 2, 2N plus 2, 2N plus 2. So the general formula for my alkanes then is 2N plus 2. Is CnH2N plus 2 for my alkanes. Okay, so the general formula for my alkanes is Cn2n plus 2. me just write it nicely. For my alkanes, if I've got my alkanes there, in order for me to know how many carbons I have, I know that my carbons, I call them N, right? And in order for me to know how many hydrogens I have, well, I call that 2N plus 2. That's what I call it. Okay, so that is how I'm gonna, that is my general formula for my alkanes. And if you draw it out, you can actually prove this is my alkane. Remember what makes an alkane? Single bonds, all bonded to hydrogen atoms. Okay, now you can actually count. Okay, so if I have N of equal to 1, my N is equal to 1, so I'll have 2 times 1, right? 2 times 1, which is 2 plus 4. So this is going to be 4. How many hydrogen atoms do I have in this compound? I've got 1, 2, 3, 4. Hence, I've got the 4 there. Okay. How many carbons do I have? I've got 1 carbon, 1 carbon. So I know that the formula works. Let's try to draw out another random alkane. I'm going to draw out 1, 2, 3, 4. Remember, I know how to draw these alkanes quickly because I know that all my carbons have to have 4 bonds and all of them have to be bonded to hydrogen. All of them have to be bonded to hydrogen. Okay, so hydrogen, 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 hydrogen. Right, what is my formula? CnH2n plus 2. For my alkanes, remember that. Okay, so what is my N in this case? Remember, N is the number of carbons. What is my N? N is 1, 2, 3, 4. I've got 4. So my N is 4. Then in this case, I've got 2 times 4 because my N is 4 plus 2. So therefore, I have 4 and I have, what is 2 times 4? 2 times 4 is 8. What is 8 plus 2? That's 10. So I've got C4H10. 10 hydrogen atoms and 4 carbon atoms. Let's confirm if that's true or not. I'm expecting 4, 1, 2, 3, 4 carbon atoms and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. So we know that our general formula works. Okay, so that's how you come up with the general formula. Okay, let's do it quickly for our alkenes and our alkynes. So for our alkenes, right? What are alkenes? Remember, our alkenes are hydrocarbons with at least one double bond. Okay, double bond. Okay, so if I've got this, I need a double bond, and I've got that. This is my simplest alkene. And remember that 4 bonds around all my carbons. 4 bonds, not more than 4, not less than 4. Always 4 because carbon wants to share all of its 4 bonds. So you've got 4 bonds, right? Since you've got 4 bonds, your thing is complete. Is it 4 bonds around all carbons? Yes, this carbon has 1, 2, 3, 4 bonds. So that's fine. And the other carbon, this one, has 1, 2, 3, 4 bonds. Okay, so that is fine. So then what I have is what? Let's see. I still want to make my C N. This I want to keep as N always, right? Because remember, we're dealing with organic chemistry, and organic chemistry is the chemistry of carbon. So I'm just gonna give, base everything off of the number of carbons. That's why I'm calling my carbon N, right? And I have H, and H needs a general formula somewhere there. We need to establish it. Remember, for alkanes, we said it's 2N plus 2. But for this one, let's see what it will be. Remember, I said for my H, in order for me to establish the number of my H, I want to multiply my N times 2, right? I want to multiply my N times 2, and I want to add on or subtract or whatever, do whatever in order to get to the number that I need. Okay, so in this case, let's see, I've got 2 carbons. So my N is 2, right? My N is 2. My N is equal to 2. So this then will be 2 times N. Since my N is 2, it will be 2 times 2. So what is this? This is 4. right? It means I have 4 hydrogens. Do I have 4 hydrogen in my compound? Yes, I do. I've got 1, 2, 3, 4. So in this case, I don't need to add anything or to subtract anything because I've got the 4 already. So I've got 4. So then this 2n is fine because I have that number of hydrogen atoms. Let's draw another compound, another alkene. Let's say 1, 2, to see if it works for another alkene. Remember, an alkene has at least one double bond. So I've got a double bond there. So that's an alkene. And I've got 4 bonds around all my carbons, all of them, right? All my carbons have to have 4 bonds around them. So that's H, that's H, that's H, that's H, that's H, and that's H. This carbon has 1, 2, 3, 4 bonds around it. Okay, this carbon has 1, 2, 3, 4 bonds around it. So that's fine. And this carbon has 1, 2, 3, 4 bonds around it. So that's fine. We know that this is an alkene because it's made up of hydrogen atoms and carbon atoms, and it has 4 bonds around all the carbon atoms. Cool. Now let's do a little trick to see if you can come up with the formula. We've got C. Remember, my carbon, I want to give it N. It's just a rule. I want to give my carbon N because carbon is the central atom in organic chemistry. So I'm going to call it N, and I'm going to base the number of hydrogen off of my carbon, right? So what is the formula there? That's what we want to establish. So I want to establish the number of my hydrogen atoms. I know that my N for my carbon, I want to multiply it by 2. I just want to multiply it by 2. It's just what you do in order to come up with the number of hydrogen atoms. And then what do? You say, okay, I've got 2n. Now, let's see if I'm going to need anything else once I actually substitute my n. Let's see. I'm going to substitute my n. What is my n in this case? N is my number of carbon atoms. That's 1, 2, and 3, right? So my n will be 3. Since my n is 3, then I'm going to have 2 times 3, which is equal to 6. Let's see if I need to add or subtract anything on the 6 to get the number of hydrogen atoms. Let's see how many hydrogens I have. Here I have 1, 2, 3, 4, 5, 6. So I don't need to add anything or to subtract anything from my 6. This 6 is actually correct because it's my number of hydrogens. So I've got 2n. Right, so from these 2 alkenes, then we have officially established that for our alkenes, our general formula is CnH2n. We've proven that. We've drawn out the alkene and we've actually counted and we came up with this formula. So we know that the general formula for our alkenes is that. Okay, so remember, we started off with our alkanes and we established our general formula for our alkanes. Our general formula for our alkanes is that, right? CnH2n plus 2. For our alkenes, we've just established that it's CN2n. CnH2n, right? Okay, so far this is what we have. This is what we have so far. So far we've got alkanes. Okay, we've got CnH2n plus 2. Easy to remember. We've got our alkenes, which are CnH2n. You don't have to memorize these. You can come up with them, and I'm only taking long to come up with them now because I'm explaining, but you can come up with them in seconds. Okay, just draw out an alkane or alkene, count, and then multiply n by 2, and then add on or take away or keep the answer that you get as it is in terms of the number of hydrogens. Now we can do the same thing before this video comes to an end. Let's do the same thing for alkynes. What is the general formula for my alkynes? General formula for my alkynes is as follows. Let's draw out an alkyne. How do you draw out an alkyne? Remember the rules. The rule is that every carbon has to be bonded to one single hydrogen. It has to form one single hydrogen bond, right? It has to form hydrogen bonds. Sorry, not one single, but remember that our compound is made up of hydrogen and carbon. It's made up of hydrogen and carbon, and my carbon has 4 bonds around it, and each bond with a hydrogen is going to be a single bond, but each bond with a carbon, with another carbon, is going to be, or at least one bond is going to be a triple bond, right? So let's draw out a simple alkyne quickly. So remember, C, what is the rule? Alkyne has a triple bond. Triple bond to what? To another carbon. And each carbon has how many bonds around it? 4. So how many bonds are each of these two carbons missing? 1 and 1. So that each one has 4 bonds or 4 lines around it. And each one is bonded to what? Hydrogen. Hydrogen. Easy. Easy, right? We just came up with this one. Let's come up with another one. Let's say, remember, C, 1, 2, 3 bonds. That's an alkyne bonded to another carbon. Let's say we increase our chain, and we've got another carbon here, right? Each carbon has to have how many bonds around it? 4. So this one has 1 bond already. It needs 1, 2, 3 more. This one has 4 bonds already. It has 1, 2, 3, 4. So this one is fine in the middle. And then this one has 3 bonds. It needs 1 more. Then all of those bonds are with what? Hydrogen. Easy. Easy. Okay. Now let's try to establish the formula for these two ones. Okay, I'm just going to do it right here on top. So let's start with this one here. Start with this one here. I have my C. Remember C, I call it N, right? The N represents the number of carbons, and I have H. And then H, I want to establish the number of hydrogen atoms. What do? I take that N, I multiply it by 2, right? And I say, okay, I'm going to get my answer, and I'm going to see how much more I need to add or to subtract in order to get to my hydrogens, right? So firstly, let's count. Let's name this one firstly before we actually come up with a formula, so that we can actually come up with our answer. How much is our N here? Our N here is 2, right? Our N, in this case, N is equal to 2. So if our N is equal to 2, N is equal to 2 there. So I'm going to say 2 times 2, and that's going to give me what? 4. Now, do I have 4 hydrogen atoms in this compound? No, I only have 2. I have 1, 2. I only have 2, so I must subtract 2 from that in order to get from 4. I must subtract 2 from 4 in order to get to my 2. So then from this 2n, I must take away 2, right? Because I took away 2 in order to get to my number of hydrogen atoms. Okay, let's do it for the second compound. Let's see if that still holds for the second compound. Okay, so here's the second compound here. Second compound is this one down here, right? So what is my N for this one? So I know I have CNH what? C here, N here is 3 because I have 3 carbon atoms. I have 3 carbon atoms, so I have 3. And then how much hydrogen atoms do I have? How much hydrogen atoms do I have? Well, I've got 1, 2, 3. Oh, sorry, it's minimized. 1, 2, 3, 4 hydrogen atoms in my compound. So if I go back down here, I know I need 4, right? So, but I take my N. Remember, my N I always multiply with 2. Always multiply with 2. And then I know that my N is 3. Okay, my N is 3 because I have 3 C's. That's 1, 2, 3. So that's 3, right? So then I say, what is 3 times 2? What is 3 times 2? 3 times 2 is 6. Do I have 6 here? Let's see if I have 6. I've got 1, 2, 3, 4. I've actually got 4. So what must I do to that 6? I must take away 2 in order to get to 4 so that I have 4. Right? So meaning that whatever my 2n is, I have to subtract 2. Just like I did with the first one where I subtracted 2. So we know that then we can safely conclude that for my alkynes, my general formula is CnH2n minus 2. You take away 2. Okay, and that's your general formula for your alkynes. Okay, so now we've established the formula for your alkanes, we've derived it. For our alkanes, we know that our formula is CnH. You don't have to memorize it, right? You can always derive it, plus 2, right? We know that for your alkenes, your general formula is CnH2n, right? And you know that for your alkynes, which we just did right now, your general formula is going to be CnH2n minus 2. And these are your general formulae for your hydrocarbons, your aliphatic compounds. These are your general formulae. Okay, so I think I'm going to stop here for this video because it's going to become too long now. But I think this is just the very basic overview of organic chemistry and the important things that you must know and the important things that you must remember. Okay, I will have a separate video where I do examples and calculations of these things, but this is just a very brief overview, almost 50-minute long overview. We covered what alkanes are, what alkenes are, what alkynes are, what single bonds are, what double bonds are, what triple bonds are, what aliphatic compounds are, what hydrocarbons are, what organic chemistry is, and basically how to draw these and some important facts basically about carbon, okay, about valency, covalency, about 4 bonds, okay, sharing of electrons and all of that. So from the next video going forward, I am going to just be focusing on naming of our organic chemistry compounds. Okay, I'm gonna be focused on naming. Okay, so we have we're gonna name our alkanes, we're gonna name our alkenes, our alkynes, and we'll add more to that. Okay, and we'll talk about more things like functional groups and all of that. Okay, so I will stop this video right here, and I'll see you in the next video. Till next time. Listen number one, listen number one. Listen number one, listen number one.